Okay, other types of equations and applications. These first ones say to decide what values of the variable could possibly be solutions of the equation. So, deciding if I want to do those or not. 12, 2 over x plus 1 plus 3 over 5x minus 2 equals 0. So we need to get a common denominator with these ones. So I need to multiply this equation by 5x minus 2 top and bottom. And this one over here by x plus 1 top and bottom. So that I get a common denominator. So on top I would have 10x minus 4. And then plus 3x plus 3 all over x plus 1 times 5x minus 2. Now, since this is equal to 0, I don't actually need to do anything with the bottom, because when I like multiply to get rid of the stuff on the bottom, that's just going to be multiplied by 0 and it's just going to disappear. So the only way that this function or a fraction can be 0 is if the top is 0. So I need to take this top part and set it equal to 0. So 13x minus 1 equals 0. So 13x equals 1 and x equals 1 over 13. Now, they say, like, not to solve, but there's not a way that you are, like, really could have done this without actually solving it. So we just had to solve that one. Okay, I'm going to jump to actually solving equations because those ones are weird. 14, nope, not 14, 18. 4x plus 3 over 4 minus 2x over x plus 1 equals x. So I need to get a common denominator on the left side. I don't really care about the right side at the moment. So I'm going to multiply this by x plus 1 top and bottom. Over here I'm multiplying by 4 top and bottom. So foiling on this first one, I'll get 4x squared plus 3x plus 4x plus 3, and then over here minus 8x all over 4x plus 4 equals x. So in this step that I'm about to do, I'm going to multiply both sides by 4x plus 4, and then I'm going to combine like terms here. So on top, I'm going to have 4x squared minus x plus 3 equals x times this stuff. So 4x squared, what is that? Plus 4x. Are we tracking what I just did there? Because I did two things at the same time. Okay. Then I'm going to move now that I've multiplied, I no longer have a fraction, so I'm going to take these things and move them and see what I can cancel out. So I'm going to, I'll leave the number over here and move all the x's over here. So 3 equals, well, 4x squared minus 4x squared is just 0, so that's gone. Add the x over, so equals 5x. So ultimately then we divide by 5, x equals 3 over 5. And that would be your answer for that one. Any questions on that one? So most often with a problem like this, we have to get a common denominator first. We multiply both sides by the denominator so it gets rid of the fraction, and then we're just left with what was on top, and then we just go from there with solving like we normally would. 22, 3 over x minus 2 plus 1 over x plus 2 equals 12 over x squared minus 4. So this one I'm going to do a little bit differently to save some work at the end. We could do this one the exact same way we did the problem that we just now did. But what do you notice about this right here? What is this on the bottom of this side? Yep, difference of squares. So what would this factor into here in the denominator? Yep, x plus 2 and x minus 2. So what do you see now that we've written it this way in relation to these other things? Yeah, it's the 2 factors. So if I multiply the entire equation, so both sides, by x plus 2, x minus 2, stuff's going to cancel. So what I'm going to do is I'm going to do these giant parentheses and multiply by x plus 2 and x minus 2. So when I multiply 3 over x minus 2 by this, x minus 2's cancel, and I'm left with x plus 2. So I'll have 3 times x plus 2. On this next one, I have x plus 2 being multiplied by this stuff. So x plus 2's are going to cancel. I'm going to have 1 times x minus 2. So plus 1 times x minus 2 equals, over here, I have an x plus 2 and an x minus 2, so when I multiply by that, everything cancels, and I'm just left with the 12 that's on top. So from the start, I have completely eliminated my fractions. Like I said, I could have done this the same way as the other problem, but this makes it a lot simpler and gets rid of fractions right away. So 3x plus 6 plus x minus 2 equals 12. I'm going to move the numbers over here and combine like terms on this side. So 4x equals, let's see, 6 minus 2 is 4. So subtract 4, so 8. And then divide by 4, so x equals 2. And that would be your answer for that one. (26) 4x plus 3 over x plus 1 plus 2 over x equals 1 over x squared plus x. So anytime I have like denominators, I always like to see if they are like already have something in common with each other across the whole equation to like cancel stuff out. So over here I can take out an x, and this becomes x times x plus 1. Well, what do we notice about that? Yeah, these are factors that are also stuff that go with this. So what I'm going to do is just like the last one. I'm going to multiply the whole thing by x times x plus 1. So up here, when I do the first term, this fraction times this stuff, the x plus 1s are going to cancel. So I'm going to multiply by x. So I'm going to have x times 4x plus 3. Plus, over here in the second fraction, the x's are going to cancel, so I'm going to have 2 times x plus 1 equals, well, over here, everything cancels, so I just have the 1. So, multiply, I get 4x squared plus 3x plus 2x plus 2 equals 1. I'm going to move everything to one side because I have a squared term. So in the last couple, I haven't had a squared term, so I've just been getting like the variable by itself and moving the numbers over. But on this one, most likely I'm going to have to factor based on what I'm seeing. So I have 4x squared plus 5x, subtract 1, so minus 1, nope, plus 1. Equals 0. So now I need to use the arch method and factor this. So factors of 4 that add up to 5 are 4 and 1. So I'm going to have 4x squared plus 4x plus x plus 1. Factor by grouping. Take out a 4x and I'm left with x plus 1. Over here, take out a 1. I'm left with x plus 1. So then these are the same. So I've got 4x plus 1 times x plus 1 equals 0. We use our 0 factor property and set each piece equal to 0. So 4x plus 1 equals 0 and x plus 1 equals 0. So x equals negative 1. And over here, x equals negative 1/4. And those would be your two answers for one like this. Actually, we need to talk about something that goes with this that I forgot about. These are both solutions, but I need to see, or well, they're both answers, but I need to see if they actually fit the equation. Okay, because what did I start with? Like, what were the things that were in the original equation? Fractions. They were all fractions, right? What can I not have in a fraction? What about the denominator?
0.
Can't be 0. So I need to look at these two numbers, negative 1/4 and negative 1, and I need to check and see if they work. So if the denominator becomes 0 in any of them, that solution doesn't work. It's what we call an extraneous solution. So does negative 1/4 cause a problem in anything? Does that cause any of these to be 0? What about negative 1? Yeah, causes a problem in more than one place. Negative 1 squared would be 1, but minus 1 would be 0, and also over here it would be 0. So this one would be extraneous. So it means it comes out as a solution, but it doesn't actually work. So our only answer that works is negative 1/4. Any questions on that one? Okay. 28. Negative x over x plus 1 minus 1 over x minus 1 equals negative 2 over x squared minus 1. So, what do you notice about this one?
Difference of squares.
And what is that going to give me if I rewrite this then?
X plus 1 is
x plus 1, x minus 1. So now, obviously, same as the factors over here like they have been in the last couple. So I multiply the whole thing by x plus 1 times x minus 1. When I multiply the first one, x plus 1's cancel. So I have negative x times x minus 1 minus 1 times x minus 1's cancel. So it's times x plus 1 equals, over here, both things cancel. So I'm left with negative 2. Gonna multiply through, so negative x squared plus x minus x minus 1 equals negative 2. These x's cancel each other out. So I end up with negative x squared minus 1 equals negative 2. Now in this case, I can use the square root property because there's not enough stuff for me to like go about factoring. Yes. No, you're good. Yes. To dismiss at 1:15 and leave at 1:30. That's for middle school and JV. Varsity is coming on a separate bus at 3:30. So you don't need anything to put in for varsity. I don't know of any going. Are any of the middle school volleyball players out today? Ava's out? Okay, then I don't know. Let me touch base with Hannah. I have like 1 or 2 more problems I'm doing in here, and then I can touch base with her. Okay, yeah, that's totally fine. Yeah, I don't know. I would think that she may take one of them, but I'm not 100% sure yet. So, yeah. Thank you. Bye. Okay. Minor intermission. So I'm going to add the 1 over. So I have negative x squared equals negative 1. Divide by the negative, so x squared equals 1. When I take the square root, what happens? X equals what? What happens when I take a square root? How many answers do I have?
2.
Plus or minus 1. Now, if I plug in a positive 1 up here, is that going to cause a problem anywhere? Yes, it is going to cause a problem because this would make this one 0. It would also make this one 0. If I plug in a negative 1, is that going to cause a problem anywhere?
Yes.
Yep, it's going to cause a problem here and also, also over here. So, this one is actually no solution. Your book may write something like this as that, which is the empty set from, like the very first section of the year. They could write it that way, but I normally just write no solution because there's no value that works for that. All right, we're going to do one more. I'm going to split this section up into 2 parts just because this section I feel like has a lot of material in it that just requires a lot of like thinking and stuff, so I'm going to split it. So 30 will be our last one for today. 7 over x squared plus 19 over x equals 6. So what's different about this one compared to the other one?
There's no factoring.
There's no factoring. What else? let's just say compared to the last one. What do you notice about all three of those all three of those things? They're all fractions. What about this one? The answer isn't a fraction. So I don't have anything that I'm like trying to pair up on both sides, but what do we have here? Fractions, okay. Something like one thing that's in common, right? They're both x, but one's x squared. So when I multiply this entire function, I know it's kind of a confusing question. I was like, I don't really know how to say what I'm trying to get them to recognize. So when I multiply this one, I'm going to still multiply everything like I was doing before, but I'm going to multiply it by the highest powered thing over here. So I'm going to multiply the entire function here by x squared. Because that's what would be happening ultimately anyways, even if I just got a common denominator on the left, I'm still going to ultimately end up multiplying the 6 by x squared because that's just how it's going to play out. So if I multiply everything by x squareds cancel in this first one and I'm left with 7. Plus, here, x and x squared, that's going to reduce to just being an x, so 19 times x equals, over here there's no fraction, so that's just 6x squared. So now I'm going to move everything to one side. I'm going to move the 19 and the 7 to the right just because I would prefer my leading term to not be negative. So 6x squared minus 19x minus 7. And it doesn't matter if you go right or left. It's not going to change anything. So first and foremost, I want to see if I can factor this. We obviously know that we can't always factor, but I need factors of negative 42 that add together to give me a negative 19. Seven and 6 won't add to 19. Negative 21 and 2. So, and the bigger number is negative because the middle is negative. So, now, I'm going to pair the 21 with the 7 and the 2 with the 6 just because of the stuff that I'm going to factor out. Doesn't matter. It's ultimately going to give you the same answer either way. But 6x squared, what is this? Plus 2x minus 21x minus 7. Factor by grouping, take out a 2x, and you're left with 3x plus 1, and then negative 7 leaves you with 3x plus 1. So then 2x minus 7 times 3x plus 1, all that's equal to 0. Now use zero factor property. So 2x minus 7 equals 0, and 3x plus 1 equals 0. So over here, I've got x equals 7 over 2, and on this one, x equals negative 1 over 3. Now, I should still check, are any of those going to cause a problem up there? No, because the only thing would be if it was 0, right? So I don't have to worry about that. So, any questions on any of those ones? Are we okay on those? All right, so I'm going to give you just 4 of these kind, just because these take a lot longer. So 17, 21, 25, and 29. You're not going to turn these in on Monday, but you should do them before Monday. I'm just going to have you turn in all of the homework for this section together. Because you still have like 20 minutes in here today. And then the rest of the stuff in this section isn't really like fractions anymore. It's like a use of the square root property and some other stuff. So we'll finish those up on Monday. And then, let me see, 1.7. We have 2 more sections, so I would say possibly next Friday for a quiz. Hold on. I lied. We're going to do a test next Friday on up through this section. Up through 1-6, because y'all need another test grade in the system, because you only have 1. So we'll do a quiz Wednesday, test Friday. That's what we're going to do, up through this section. So I'll finish this Monday. Tuesday will be review, Wednesday quiz, Thursday review, Friday test, and then we'll do the last 2 sections of this chapter, and they'll just have their own quiz, and that'll be it. Yes.